to welcome you all to the 14th webinar organized by ROMA. And I thank ROMA for inviting me from Supreme Industries to welcome our guest speaker. Supreme Industry is a professionally managed company in the field of plastics. We have Sri MP Taparia, Sri S.J. Taparia and V.K. Taparia, who had been giving their dynamic leadership to make Supreme the leading plastic manufacturer of the country. PVC, CPVC pipes, SWR systems, various roto molding products, and protective packaging, films, etc. In roto molding, Supreme has emerged as one of the key producers for the underground roto molded product. So manhole covers, manhole chambers, now sewerage systems, inspection chambers, and toilets, and waste management systems, and different type of storage tanks. So Supreme has also been producing pellets, beans, crates, even some customized products through roto molding process, which has made Supreme a unique manufacturer. We at Supreme have been seeing ROMA take shape, grow into an association wherein they are supporting the Indian roto industry so that we learn technology and have a global connect. I think to this endeavor, today is a big day for them in this webinar, organizing this webinar. So I am here to welcome Mr. Oliver Wandres of Moulds, Germany, as the speaker of the 14th ROMA webinar. Especially the topic of today is high quality molds and beyond. Oliver has been the general manager of Moulds, Germany, the rotational mold, and actually represents the 4th generation in the company. Moulds started in 1925 as a pattern making company. However, in the mid-80s, they have transformed themselves into a specialized roto molding manufacturer. Since then, Moulds have built a good reputation globally as a high tools manufacturer and also superb service provider. But they are not limited to that. They have been recognized for a lot of innovations in roto molding that they have brought. Like to name a few, it is BMC coatings, Moulds holes, then fast casting. We have got hybrid molds, roto coolers, dump box, and many more. Oliver has an MBA degree from Technical College of Time. Oliver has been involved for 25 years in industry and is a frequent presenter for various roto molding conferences all across the globe. Since 2007, Oliver has been the president of RC, that is the German-speaking Central European Roto Molding Countries Association. And also in the year 2015 and 16, he was the chair for ROMA. So I would not take any further time from this valuable presentation or the webinar. And I would like to hand over to Mr. Oliver Wandres. Yes, Oliver.
Thank you very much, Anshuman, for introduction. Thank you, Roma, for inviting me to this webinar, and welcome all. I hope you're all well. And yeah, since I have quite many slides to share with you, I'm just kicking in right away. We just need to share my screen, and then we should be ready to go. So today I'm trying to talk a little bit about the high quality rotation modes we are doing, but also things beyond the high quality, but you will see that. Okay. So you should hopefully all see the screen. So I have interrupted the presentation in first a short and brief introduction, the high quality rotation modes. So we are doing some information on mold automation, gadgets, and possible accessory, but also on mold maintenance. So starting with a brief introduction about the company Moulds. Also, you heard a little bit already from Anshuman. What is very important, we are a company with a lot of history. As the company was founded by my great-grandfather back in 1925. What is really important to me, we're actually one of the pioneers in rotation mold making, as we started to make our first rotation molds back in 1962. Since then, we have more and more focused on rotational molds. As you heard, we had many developments, especially design for rotational molds. One of the latest developments are the electrical heated molds for robo molds, but it's a continuous process. Every time we come up with new things, we always look right at rotomolding. We are just trying to make other things work for rotomolding, but we develop things and techniques for rotomolding. In terms of our services, we separate this in a lot of services upfront, actually before the actual mold making. So we assist in design, construction, we can help you pattern making for re-engineering. We also do prototyping, prototype molds. And beyond the mold, we also have a lot of permanent mold coatings, which we have developed, mold accessories, repairs, refurbishments, anything we can do with an already existing mold. But of course, our main focus relies on the actual mold making. And here we have all sorts of possibilities. We make the molds from aluminium, either CNC machined or cast, but also fabricated aluminium sheet or steel sheet, but also galvano molds. So nowadays we can say we can offer all common mold types which are used in rotomolding. So as said, we have galvano molds, we have the sheet metal molds, we have traditional cast molds, but we also have the so-called fast cast process, which we developed ourselves. The CNC machined molds, but we can also combine different parts of these in one mold, and then we actually speak of a hybrid mold where we use different processes to always get the best for the mold. It is also quite important to consider the different types of molds we are producing. So we cannot only produce standard serial molds, but we also produce and lay out the molds as so-called prototype molds if you would not need as many predicted numbers. But we can also have semi and fully automated molds. Certainly we produce combination molds, robo molds, but also molds that are heated by infrared, or even molds which are heated by an oil jacket. So it's different types of molds. When we speak of a high quality mold, when we consider the mold as such, there are certain components that almost every rotation mold would feature. Here we see a very old picture of a children lamp, a famous character in Germany. I think that mold dates almost like 25 years old, but still it's still the basic components. We do have the mold shells. We do have mold flanges. We do have centerings or dowels for having the right orientation on the flanges. Typically, a mold would feature a mold frame, and you would also find some elements of fastening or clamps to actually keep the mold shells together. And you would have most likely a breather or vent inside the mold. So when we look at those things, it is for us very, very important to look at the first part, the mold shells. If the mold shells are not good, or in other words, if you have a bad mold, it's pretty damn hard to produce a good plastic part. So it's most important to look at the mold shells would require to have a very good heat transfer, as you want to get the heat in as quickly as possible. But it also should have even wall thickness to get a good. You would also want to have the mold shells be very uniform. As every thickening you would have the mold shell. As every uniformity on the mold shell would also give you a different wall thickness on the product. It is the metal quality which is very important. It's the rigidity. You want to have a mold which is not becoming brittle. You would not like to see stresses being included in the mold shells. You should ask for a certain quality, surface finish possibility on the mold shells. Depending on the parts you produce, there should be also a certain accuracy involved in the mold shells. So they should be spot on in terms of the dimensions you want to achieve. But you would also have to consider what limitations would there be in terms of the mold shell production. So those are all questions to find the right mold shells. And let me just introduce a little bit of the different processes we have to actually produce those mold shells, starting off with the famous calc casting process, which was developed especially for rotation molds. What is outstanding here, it is an aluminum casting process, but unlike any other process, the process is actually designed for making rotational molds. So what was most important for us is to have a way that we can produce mold shells which have only a 7mm consistent wall thickness. And that is really very outstanding and very important. Nowadays, you can find many people CNC machining molds with 7mm, but why is it that all casted molds typically are a lot thicker than 7mm? Because it's technically quite difficult to achieve this thin wall thickness. But it's very important to keep the mold as thin as possible to get a very quick and good heat conductivity or heat transfer into the mold. With that process, it's also possible to cast in undercuts. We do not need any demolding drafts. We can have fine surface structures. So as said, it is specially designed for the needs for rotational molds. And that casting process you can only find by us in Germany and by our partner Norstar in US. Some examples on how this process works. Typically, we will start off with a positive model. As you can see to the upper left, there was a product for the royal family of Thailand for some ornamental sarcophagi. So they provided a positive model, which we used to actually give shape to flexible resin negative skins, as you see in the upper middle. This is then the basis for actually our casting molds. So from this rubber skin to the right, we will then produce the casting molds. And unlike other foundries, we will not cast sand on sand, but we are actually working with sand and ceramic to have two opposite materials, one actually tracking the heat and the other one storing the heat. And that easy principle helps us to achieve 7mm thin wall thickness, where we have a very crisp finish on the molding side, and a very rough finish to the outside, which in rotational molding, actually it's even good if you have a rougher outside, because it is then accelerating the heat transfer. So you can see the product being highly loaded with structures. You can see in the middle the final product, which is then actually even gold plated and painted, so quite an ornamental part. And only these type of fine structures is possible with this calc casting process. But since we always need to have a positive model for the calc casting process, and taking time and cost, we have to put quite some efforts in developing a more fast cast process, where we're trying to skip the positive and the negative models, but go straight to the casting molds. So here we are actually CNC machining our casting molds. So again, the casting molds are formed from sand and ceramics. So that means we're actually CNC machining the sand and the ceramic. So we cut the positive models, we cut the negatives, but we need to have more CAD engineering to actually model up those needed mold shells to then CNC machine the casting molds and do the casting. So with this process, we have no compromise in quality and accuracy of the casting, and we can actually speed up processing quite a bit, and at the same time drop cost for materials. Very important for us, if we talk traditionally or fast cast process, it is that our foundry is very dedicated for these purposes. So high quality thin wall casting. We nowadays have a casting capacity of 3,000 pounds at one go. As you can see in the pictures, we can produce really large products, such as that boat. But also to get the best features on the molds, we actually have our foundry building humidity controlled. Every melt we produce every day will be checked with a computer system to provide that we always cast on the same environment, but also on the still every day the highest possible quality of the melt we produce. Plus, we only work with a 100% virgin material, so that means we are not recycling our material, as this would reduce the quality and the longevity of the mold. That is some more recent pictures on a nice and big product. So that is actually, to my knowledge, the largest lamp there is in rotomolding. That is a light shell for probably one of the most famous German soccer club. So it will be a light shape which is 6.5 meter long. And almost 3 meter in diameter at the biggest end. So as you can see, we actually had to chop this in different sections. We can then weld this together. So basically it works as a 3-piece mold. You can see on the pictures to the upper side, this is the CNC machine sand. Once we poured the pieces, they need to be brought together. A highly stiff and stable mold frame. And as you can see with the guy standing next to it, it is quite a decent size for a light shape. Actually, this will be produced on a rock and roll machine. Yeah, we also make CNC machined molds for the mold shells. This is more ideal if we talk about flat or shallow mold shells, as we don't have to cut that much material. There is the limitation that the machine heads need to be able to get into the contours. Other than that, there is not much of a limitation. This will give you the highest dimensional accuracy if being done right and if the machine heads and cutters being good. But it can give you the best quality. Just a recycled slide from another presentation to give you some idea. Nowadays we have 22 CAD/CAM workstations where we do programming. We have 10 high-speed cutting CNC machines with a maximum dimension of 6 meter by 3 meter and 1 meter 60 in set. So obviously big enough for the largest jobs that they are out. As on the example picture you see here, that was a tractor roof for Mahindra, being actually cut from 4 pieces to speed up timing, and that mold was produced as quick as in 5.5 weeks from date of order. So it can be quite a speedy process. That is another rather large process for CNC machining. Also, we say typically we use CNC machining for flat mold shells. This is, as you can see on the left picture, quite deep. This is in total, that shop contained 25 tons of aluminium billets, but it was cut from one solid billet rather than putting these together. So as you can see on the picture on the right, this will create quite some chips. The thing is, you actually have to pay for the full material to then end up with only 700, 800 kilo of mold shells. So there's a lot of waste, which makes CNC machining of such deep and large pieces quite costly. So therefore, we always think about what is the best way to go. Is it CNC machining? Is it casting? And many times you will find a hybrid will give you the best features. As you can CNC machine the flat pieces, you can cast the deeper pieces and put them together just as you wish. That is a picture of the finalized CNC cut mold. Again, as said, this was made from 2 solid billets, so quite material intensive, that job. Frame being FEA tested due to the size and weight of that job. And this is the actual product. So it's a jet ski dock station, actually the largest and widest there is in the market. Right, okay. So now we talked a little bit about the mold shells. Next on the topic is the mold flanges. Of course, it's important to consider the right dimensions and the strength of the flanges, because this is holding the mold together. So you don't want to have this too weak, but you should also not make it too thick, as then you would have a heat sink. The meeting of the flanges, they could be machined from the CNC machine or glued together with an engineering sploot. You want to have the mold flanges set up in such a way that you don't have too much offset or distortion. You need to design the mold flanges in a way that they can be as tight as possible, so you don't have leakages on the mold. In some cases, you could also consider to implement into the mold flanges some sealing gaskets to actually avoid material dripping out of the mold, but also to minimize trimming works on the molds. As on many molds, we actually design in recesses on the flanges to enable the breathing of the air, which is encapsulated in between the mold flanges, to the outside, rather than creating bubbles along the parting line on the plastic products. Some examples of that, that is a mold where you can nicely see, in this case it was a cast in omega shaped groove on the mold parting line, where we could then easily, that is the groove here, where we could then easily put a silicone gasket in there to then have a sealing gasket for the mold, which is then helping to have this quite nicely and sealed. That is just a picture from a refurbished mold, but here you can actually see quite nicely what I mean with a recessed flange. So we actually only have 10 millimeter inside the mold surface, a meeting face, but we have machined out or cast out a little recess to the outside. So therefore we have the clamping force right to the inner side of the mold, versus the outside is nicely opened up, and all the air will stream to the outside. If the mold is heating up and air is expanding, now the air will escape to the outside. So that is helping you to make better products. We could also have much more complicated so-called dispersed flanges. Typically a flange is meeting face to face, flat on each other, which is always creating a heat sink, which typically you can see if you cut the product. You will have differences in the wall thicknesses in the areas of the mold flanges. If I talk about dispersed flanges, then we don't have the flanges meeting face on face. This is actually a liner for the aerospace industry, and they were most critical on a as homogeneous wall thickness on the product as possible. So we have set off the flanges. You can see this better on the next picture. If you look to the picture on the right, we don't have the flanges meeting face on face, but they are actually ripped with little pockets, so the air can stream everywhere. We have no thickenings. We still have a good meeting point on the mold shells, but the flanges are actually separated apart and not creating any heat sinks. The centering systems on the mold flanges, they are also quite important, because if you don't have a proper centering without the years in production, the molds will start to grow and distort, and even if you would start off with a good meeting face or meeting shells, they could be coming off quite a bit in the production. So typically when we talk about centering systems, we could have so-called dowels in the mold flanges, or we would find tongue and grooves. It's important how and where you place them, but also how you could fit these systems. Especially with the dowels, it is a matter of how many dowels you would produce on the molds. Some people tend to have way too little dowels, and this is giving you quite some difficulties further down the road in production. But it's also the style of the dowels. Some dowels are just being used from other industries, and they are not really meant to work with the needs of rotation molds. Sometimes it's the material of the centering systems, which I'm not really 100% in agreement with others. But we also need to consider the maintainability on those centering systems, as they are quite important. When I look into the industries, we still see many molds with tongue and groove. Especially some countries are quite reluctant to move away from tongue and groove. Here we have one example of a mold we had to refurbish in our shop, where we had to implement a PTFE spacer in between to separate the two products. But you can see on this product quite nicely what is the biggest disadvantage on the tongue and groove. It is quite hard to keep this nice and tidy. There will always be material penetrating into the groove, and with the tongue you actually condensing the material, you bake this in. It's very hard to keep this clean and tidy, and if you have material buildup, it is actually degrading the good fitting of the mold. And then if the operator is trying to actually clean it and rub this out, many times they actually scratch and hurt the mold with the wrong tools. So in my opinion, a tongue and groove should only be used in certain areas where you have a deep slope or something, but not on a mold as a standard item. In the past, we typically used cast dowels, which are good if you put the mold together and you don't pay attention and you hit it wrong. It's actually aluminium hitting aluminium, so there's not much damage done. But still, as you can see on this product, this was an old fender for Mercedes-Benz, which have already been producing for 20 some years. The dowels, which looked at the beginning like segmented domes, now look more like balls. So there's quite a wear and tear happening on those aluminium dowels. The funny thing is, sometimes in the industries we actually have customers, they want to go for tongue and groove and steel dowels. So to me this is like Hosenträger and bells, so not really useful. At the end of the day, yeah, you need to know what your production team wants to have. Typically, for us, when we make the molds is nowadays to use steel dowels. Actually, the steel dowels are produced and designed for rotation molding, so they are nicely for fitting the molds together, so they are not too straight. They actually will allow you to open the mold with an angle of 30 degrees, but still giving you a very, very tight fit. If we use those steel dowels, if we go for the foundry, we'll actually cast in steel bushes into the mold flanges. So we're not placing these afterwards, but the positions are perfectly set from CAD right into the casting, and into that cast in steel bush we'll install the steel dowels. The steel dowels are hardened. They are easy to take out for cleaning the mold flanges. You can flip them from upper side to lower side just as you wish. But I think what you can also see on this product, and this is quite typical, you should have not too far away distances from dowel to dowel to keep the mold in a very tight and good fit together. So typically in our mold production, we would not go beyond 250 millimeters of distance from dowel to dowel. That is the farthest distance we would consider. The mold frames, also quite important, should assist you, of course, for the closing, opening of the mold, but also will give you certain features for the handling of the mold. You want to watch and observe the dimensions and the weight, as typically many times the machine, or especially the arm, will work as some limitation, but also in terms of storage. So the mold should have not too much framework, but enough framework. So it's a quite sensitive area to get the frame designed in the right way. The frame also works as the adaptation to the machine, but it should also keep the forces of rotation molding and adopt the forces of the movements. Should also protect the molds if it's on the mold, but it might be also in storage area, or if things actually would drop, if you have no frame, then the mold shell will be directly infected and hurt. If you have a proper mold frame that is actually caging up the mold, there is less damages on the mold. Also, the mold frame needs to compensate different expansion rates, especially if you have aluminium molds. It is not easy to just simply bolt a steel frame onto the mold, as the steel expands in a different way, so it might actually pull and distort the aluminium shells. So there needs to be certain knowledge about how to apply this. And it might be even so that the mold frame does not be made from steel, but it might be also made from aluminium. To give you some examples, this is again a recycled slide from previous presentation. This is what we call a space frame. The picture on the right, where actually the frame elements is being formed directly from the CNC machined mold shell. So it's nice, it's spacious, it gives a good airflow, but still that cut frame element works as a very nice and stiff frame for the mold. At the same time, it makes also the mold very light, very easy for the operators to work with such molds. We also make molds where actually, you see on the left side, where all the frame elements are actually CNC cut from aluminium. This is a quite intricate design on a rain bucket here. You will have CNC machine lines in the mold, which in the product will give you like shadow lines. So actually it looks more like a two-painted product, but it's not. It's just the light and shadows on the product that shape these nice little lines. To achieve this, as you can see in the middle of that picture, that mold element is actually produced from two pieces bolted together. And in order to not having the mold shell to pull away that very fine detailed contour lines, everything was made from aluminium and bolted together. So we have absolutely zero distortion within the production in rotation molding. Another element where all the frame elements were produced from aluminum tubing, so it keeps the mold nice and light, but obviously it cannot be as rigid as a steel frame, and obviously it's also a bit more costly to build. Especially for larger molds, we recommend to have some sorts of spring elements in the frame to keep up with the different expansion rates. But what you can also see nicely on that picture, whenever we make the mold, we would not apply the steel frame simply on the mold flanges, but we have little upstands on the flanges, so-called mounting domes, and these alone will work as a little expansion rate between the aluminium shells and the frame, as they can slightly being pulled away with the different expansion rates. Also, this picture shows a rather large water tank with 6,000 liter, where we're not using hand clamps but automatic pneumatic clamps. That takes me right to the next point, the fastenings on the molds. We could have clamps or even bolts. Bolted or screw flanges. You could even work with just vice grips. You could have bolted receivers. We could have hand clamps right on the flanges, or we could have hand clamps on the mold frames, or we could even see automatic clamps. So there's a wide range to choose for. You just need to find the right elements for the job. Not necessarily we make all molds with clamps. So this is a job we made for Maserati little air ducts. That mold is as tiny as a A4 paper. So you can see it's very, very simple, bolted together with wing nuts. It's a 4-piece mold. That's doable. It's not a product which is of producing high numbers. They only use for a very distinct car, only like 30 of those air ducts per year. So it would be a waste to actually have a full frame. Therefore, it is as stripped as possible, very easy, just with wing nuts. We make products where we use bolt and receiver. As you can see, it's a spring-loaded bolt, which you will work with the air wrench. If you screw it out, the spring will help it to pop out. It's quite noisy for the production team, but it's good as it is probably the narrowest space to actually clamp, so you can go into the narrowest distances on the mold. We could also have the clamps on so-called prototype molds, where we just have the clamps sitting right on the flanges with almost like no frame. But I would only recommend this as said for prototype molds, because sooner or later in production you would have distortions, you would have not enough closing pressures. That is another prototype mold for Porsche water tanks. As you can see, everything being produced quite simple. The frames being put right on the mold shells, trying to make the mold with as little effort as possible. That is a larger CNC combination mold. As you can see here, it's typical, it's more the typical style of clamping. So we will have manual clamps, which are installed on the mold frame elements, which will pull the mold together and keep it nice and tidy and closed and sealed for many years in production. We can also have automatic clamps, and hopefully that one goes with the transmission. I will try. This is a little video clip. As you can see, that mold is like fully loaded with big pneumatic clamps to actually close the mold, but it's also with pneumatics for pulling out panels, for pulling pins, for basically doing all the movements which are needed on the mold will be done by pneumatics. So as you can see, if we applies air, the clamps will actually lock that within seconds. So rather than walking around the mold and closing, it'll just being happening by the compressed air, which is applied external compressed air. It's really like seconds, and to give you some idea, that mold in total weighs like 1.5 tons, and only we need like 6 of those big pneumatic clamps. Right, then we have as last component of the molds the breathers or the vents. Most common, wherever possible, I would recommend this is to have an open tube that goes into the center of the mold. Obviously, not always possible on smaller molds. Typically, we will find filters, steel tubes, typically closed with steel wool or something comparable. We have the family of the Super, Smart or Intelligence from Laplace Technica in New Zealand. We could also consider pressurized production or inner air cooling for the breathers. To give you some idea about systems we provide, this is like our one-way breather systems. So as the name says, it's a one-way system. After each and every cycle, you're actually replacing that filter vent. It's a very good and low-cost system. What is neat about this system is that actually every cycle you have the same venting properties. So there is no messing about if the operator would condense the steel wool too harsh or too little. Every time you produce a product, you have the same venting. We would have the family of the Super and Smart Techno vents and Intelligence. These are silicon vent tubes, which depending on how they are installed, can see quite some production numbers before having to be replaced. So we would actually recommend to install them inside a PTFE sleeve or retainer, as then the lifespan is greatly increased. Again, the idea is to have a venting that is giving you multiple products with a very similar venting properties, and not like with a common system where every vent, every cycle you have different venting features. That image shows a rather large hybrid molds. So again, on the right picture, you see, for example, a sheet fabricated lower part on that tank, versus the upper lid is a fast cast lid. But what is important here, rather to keep that production line on a good pace, we have implemented for the molder an inner air cooling system. As you can see on the top, actually where the guy stands, see that one, you can see here or here some inner cooling systems where we can actually utilize a venturi to blow inside the big and open vent tube, trying to fully exchange the air volume in cooling. And with such a way, you keep the product longer to the mold wall, which is reducing warpages, but you actually can also reduce cooling time easily by 10, 15, 20%. So a very easy system. All that it will require is enough air pressure from your machine arm. Just slide it in. When we think about the aluminium shells, and this is rather new to us, we have the last few years invested quite heavily in new welding technologies. That is a cat picture of a cooler box. And nowadays, with our state-of-the-art welding technologies, where we trying to implement the shortest heat as possible to the areas where we want to weld, we are not creating any distortions in the metal, nor would we change the density on the weld lines of those areas. and we can actually do chemical or ultrasonic controls of the produced weld joints to make sure these are absolutely sealed. So what this would mean on a product, again, this is an example of a cooler box. You can see in this product that it's a typical cooler box. It's a very easy outer shell, but it's also a core section forming a twin wall product. Where we have put the areas together, we have no flanges, so there is no doubling of the wall thickness. It's not creating any heat pockets or heat sinks, but it's just the wall thickness which we put together and weld together. Outside, as you can see here, it is just ticked, little areas being ticked, or the same happening on the inside, on the core section, so little tick welds, but to the inside it would then be seamlessly and fully welded. And by this we actually achieve a uniform wall thickness without any heat sinks, and also with a very even density on the metal. This is as it would look like in CAD. So we actually split the mold shells, create a little chamfer on those areas where we'd like to weld. So you can see this is on the lower pictures as it should look like. This is in reality, just showing you, this is then the finished mold shell. So you will not be able to tell where it was welded, as this is with that new welding technology, you can put these elements together without any high lines. It's invisible. It's not very easy to do, but we are actually quite happy that nowadays we are able to put these pieces together. Again, you would see no differences where those pieces have been welded together. Here again, you can see nicely on the area, if I highlight this, you can see from the outside where it was welded, but you don't see it on the inside. So that is giving us new chances, where before we said trying to stay away from patchwork mold shells, but with this new welding technology, it actually is an option to do such patchwork molds. So that was just a brief overview on the different mold elements. I hope there was some useful information in for you. The next topic would be to give you some examples on mold automation, mold gadgets we can actually offer, or mold accessories. Again, we have seen a little bit of this already, the mold automation. We have developed all those pneumatic cylinders, especially for rotation. They can pull, push, or close, whatever movement is needed. We nowadays can achieve this with pneumatic cylinders. This is an example of a mobile toilet pallet, where you can see the mold is not only being closed with pneumatic clamps, but also all pull pins being installed on pneumatics. So the operator would only have like a little tableau with elements where he applies the air, and the air will do all movements. Good thing about this is you don't need physical force, but also the pneumatic cylinder will do the movements every time in the same manner, so there cannot be any damages. Typically, we use the automatic clamps also on spiders, trying to compromise or condense the space on the machine as tight as possible. So if you look at that platform on that spider to the right picture, it is very tightly packed, and you could not do this so with normal manual clamps. Same picture here, you can see on the left side many molds installed in the spider, and when you look into the right picture where those molds are actually opened up, you can see that there is like almost zero wasted space on the machine. It is almost like fully packed. a little case study on a product, little furniture.
ফাইবার হচ্ছে হয়ে গেছে হয়ে গেছে হয়ে গেছে।
So here we have two sets, two mold sets on one spider. So actually it's 4 little piggies, 4 noses and 8 ears. So you see the different molds installed. What was a bit tricky on that product is actually that the belly of the pig was requiring a third mold piece. So with slides and little systems, we achieved a way where when you lift up the mold, the product will actually be stuck on those belly pieces, and then you can just easily pull this away. So it's both, it's automatic, but it's also a clever design for the operators to actually work with the products. Again, you can see with those pneumatic clamps, it is possible to really condense and compromise the molds next to each other. Of course, you always have to watch out for the air volume or air streams around the mold. So it should never be too tight, should not always be on the same levels. With these molds, you can see these are C30 coated. So this is giving a satin matte finish on the product. Again, a little movie clip, and perhaps it'll show when we lift up the product with a crane, you will then actually grab the belly pieces. So the belly pieces are only closed if the mold is put together. But if the mold opened up, you can see that this belly piece, show that one, is hanging loose below the mold, upper mold and the lower mold. And here is where they then can just easily pull away the plastic product. We do have automatic spiders for singular molds, or in this case, it is 2 singular molds which are automatically clamped together in a somewhat baby spider. It's a 2 mold spider, but these are also produced in such a way that we can easily exchange these and put different tanks in there. But it's not only the closing, but it's also the pins and threads which are being produced by automation. You can see again the clamps for closing, but you see there's a certain amount of cylinders involved for actually retracting certain elements on the molds. Yeah, this is in reality, there could be, for example, if we try to see this, you can see it is just being produced by the compressed air from outside the machine, which you can use for opening the clamps or actually closing those clamps. And besides the clamps, we then also use the air for opening cylinders, retractable pins, whatever. So it's a fully automated mode. What we also do is robo molds, and that is by far the most automated molds. So the robot is doing both. It's the molding, it's electrical heated molds, but also the robot will do all the handling. This is an example of a large hydrogen liner, which is almost 2.50 meters in length. So it requires many electrical heatings, but this is really good for a serial production of very sophisticated products, to 100% cutting the labor forces. When we take a look inside the mold, you can see our newest coating, which is called the Edelweiss. You can see a sealing gasket in the mold shell. So a lot of those things which I had already talked about. This is as the mold looks without the robot. So you can see many heating elements. We have sliding elements for the cables, etc. Yeah, well, that's more like for automated production. where here the robot would take the full molding. It would actually take the material, mold, form the product, demold the product, drop the molded product on the belt. So it's completely labor-free. To talk a little bit about the possible gadgets we have produced, one is the so-called rotor cooler, which we had developed together with the Queen's University. This is a device where we can actually introduce inner water cooling inside the product. The inner water cooling is especially good for rather large products, as it helps to exchange the hot air inside the product, but it's also with the water mist we introduce, takes all the heat energy and transports it out through the breather. So it's a very quick cooling method, but it also creates a little pressure inside the product. And also being able to cool from the outside as well from the inside. This is a really good way to minimize distortion on the product. So on the picture on the lower side, you can see the left product being produced with the rotor cooler, so it's fairly flat, versus on the right side, you see the product being cooled conventionally. So you have on the flat faces quite some warpage issues. So the rotor cooler can help you to avoid this, but also helps you to speed up cooling process quite a bit. Here we see the rotor cooler installed on a mold, so it's on the lower side, we see the picture with a blue silicone cap. This is where the rotor cooler will actually introduce a lens and then produce a water air mist inside the product to help to get the heat out. Similar like with the previous picture, that you see what differences this can do. To the left, when you look at the upper right picture, the product to the left is showing you a very flat face. This is produced with a rotor cooler with no cooling trick, nothing, just as it comes out of the mold, versus the right product being cooled conventionally, and you see quite some distorted surface areas. So the rotor cooler could be something in terms of mold gadgets. We also have drop boxes, or we have what we call the mouse holes, which we had invented. This is silicone materials which we can cast to any required shape, implement into the mold, and this will actually form and shape openings in the product, similar like a PTFE or PEEK, but with a big benefit is being a flexible material and a lot cheaper to produce. So here in this particular case, it is an intake, air intake for a tractor. And as you can see on the picture on the left, where we see the mold, which is carrying different surface coatings, and you see the blue elements. This is all little silicone studs being stuck right into the mold wall. And to the right, you see the product that is produced with this mold. So it has all openings already directly formed in. Another example of an engineered mold. This is a tile, a roof tile for the UK, where we need to find a way to actually hold a little mesh material in the product to form like a little net to avoid insects getting into the roof tile. So you can see on the mold engineering we have little hidden hinges and slides. We have this area where we can place the mesh material with clamps which will pull it in place, but we have also certain elements which are formed with the silicone to create an opening where needed. So you can see here that we have a silicone on the top opening, but we also have silicones on the front faces where there is an opening, but still we have that mesh area which is embedded into the mold. So it's not allowing the insects to go in. Yeah, then we also have permanent mold coatings. I should not do a presentation without naming permanent mold coatings. We nowadays have developed 12 different permanent coatings. They all have a certain job to do. Basically, all of them will permanently release, but some will enhance the product, some will create a brighter look on the product, etc. With our permanent mold coatings, which are known to the industry as BMC coatings. We have also our partner Reinhardt Technique in India, which is able to carry out the coatings there for you in India. So that is cutting traveling hours and costs of the products and molds. Why should you use or consider mold coatings? They will release the product, they will give you greater quality of the product, they will reduce your maintenance work, they will reduce scrap rates, the product will nicer, it will be more repeatable as you don't have to mess with the semi-permanent release agents. It is also helping you to cut down costs as a permanent coating will be installed one time versus a semi-permanent release coating you have to redo multiple times, which is also creating scrap pieces, cost you the liquids of the release coating, but it also steals away quite many cycles in production. This is our latest adoptions on the coatings, what we call the Edelweiss coating. Mainly it was designed for the flanges, and as you can see on the picture, the mold flanges had been coated with the Edelweiss. The Edelweiss is like a ceramic coating, so it's very, very tough, very hard, but also very smooth, very easy to clean off. Plus it is quite strongly releasing, so material will not tend to stick there. The Edelweiss coating on a larger inspection chamber. Also, you see the inspection chamber carried out here with pneumatic lamps. What is also helping a lot, as simple as it is, the white coating really helps the operators to focus on any contaminations on the mold flanges, as it really stands out proud if there is some contaminations. The white coating shows this. You clean this out and you're ready to go with the next cycle. And while it is so hard and yeah, smooth as glass, it's very easy to clean the molds. Lately, we also found that the Edelweiss coating will give a good molding properties when we coat the molding surfaces. Again, very nicely to spot any contaminations in the mold. So you're always producing clean and nice products. Gives a very nice glossy finish on the product. What is very important to many of our customers, that coating is actually food-proof and certified by health industries. Yeah, that's the Edelweiss coating. Many times we think about, we say intelligent mold conceptions. It's not that we just need to produce a mold with good mold shells and good flanges, but we also should always think about the handling of the mold, of the guys that have to work with the mold, but also how we can demold the product. So it's a full story. What does the mold have to carry out? How would the guys have to work with it? So here in this case, you see many times we have like slides which could be on a slope to enable the right demolding systems, trying to avoid damages on the mold, trying to avoid that operators can do any mistakes, trying to make the molds as easy to work with as possible. So in some cases, it can be easy hangers for any inserts or pull pins, so that the guys don't have to pull these on a workbench and trying to mix them up. So very easy systems. Or we would have slides where we can slide out molds and pull away without surface areas being hit and damaged. It could be auto brake systems where if you use a hoist on this mold and apply to the 3 hoist points with lifting the mold shell with the hoist, actually this will simultaneously break away the molds on 3 points rather than having to use a crowbar where always you would have a one-time spot force. This is doing the breaking off in 3 points at the same time. Here we see a mold where actually when we open the mold, they can easily pull or tilt away one mold side, but this is then being held with like spring stoppers, so it's not falling all on the mold floor, but just being pulled away slightly. In terms of mold accessories, we carry snapserts, which you can use for holding inserts in a very quick routine, so you just stick them on. They come in different sizes, but also different features, so they could be standard snapserts, but also double snapsert, so you can use inserts with wider tolerances, or also hot sets, which are meant to actually adopt much more heat, so you get a lot of heat on the insert, which is then ultimately working in a lot of material melting around the needed insert. We have offered and produced certain Venturi systems, which are probably the most efficient Venturis you will find in our industries, as they are designed for rotor molding, so they're easy to adjust. And if you use them right, those Venturis, and if you think about buffer plates where you can lend the airstream, this would be a very efficient way to heat up mold elements. Another spare or accessory product will be auto ejectors. If you have a part like this where it is very hard to grab and you have some areas where the product on those black fingers, the product will be really stuck. To be able to demold this very easily, that product has like 4 auto ejectors where with air the product will be nicely lifted, simultaneously lifted out of the product. So you see here on the little movie clip, if air is applied, those 4 little stamps will actually nicely being pushed out of the mold.
Mr. Oliver, the voice is not coming now. क्या हुआ इसमें?
Strategy went through.
Mr. Oliver, can you slide your show? I think some network issue is there. I think reconnecting.
Suddenly it's gone.
Yeah, I think network issue is there. It's reconnecting now.
So, is it connecting? Good.
LK sir, can you call him?
I should call him?
Yeah, I think some problem is there.
Yeah, I will call him. Hello. Teddy ji, can you hear me? Teddy ji?
Yeah, Alke sir.
No.
Alke sir.
I spoke to him. He said he's trying. His computer went blank. So he's excused. If you give me a few minutes, I'll just come back.
Yeah, sure.
Okay.
No problem.
I never expect German equipment to go down. Indian equipment हो सकता है, but नहीं होता है, क्या कर सकते हैं इसको? But it'll happen. I'm sure he's trying very hard. कभी-कभी हो जाता है.
No.
But very interesting presentation.
Yeah. Good.
New
Yeah.
ideas, new concepts, and so on. But I
Right.
think Indian industry should consider patronizing and so on. Yeah, the tied up the done well. Yeah. Or Baki, we have, I don't know, almost 60, 70 people.
Yeah, more than that. Yeah, almost cross 100.
No, more than 75. It reaching by 85.
85, excellent. No, excellent, very nice presentation. It's a pity खराब हो गया, but I'm sure अभी आ जाएगा तो it'll be good, ना?
Almost entire industry is sitting here.
Very good. I'm really glad. Yeah. नहीं इसको बोला, he was hesitant. It took some time, but 2-3 बार बोला तो फिर मान गया. He's done well.
Yeah, that's good. Yeah.
नहीं इसको किया, I've passed on many customers to him also. So फिर he done.
Good.
He come down. No, he done well. I think I would do.
It's a very good presentation. Very informative.
It's something new ideas, new concepts he's doing. So it's good for our industry. So this quality will grow. And they have a future here because Europe is pretty well saturated, but India has a very good chance to grow.
Correct.
So I'm sure they will develop very well. But anyway, ROMA has been successful. Is it coming on?
Joining, yeah.
Yeah, good, excellent.
Strike. Yeah. Yeah, he joined.
Good. नहीं आया अभी तक? मनोज?
Still waiting, sir.
अरे यार And the last thing I expected. At least not from Oliver. कमाल कर दिया.
We have got a lot of ORCID participants. Also welcome
We
them.
can, Shariji, we can, you welcome some of them. Also ask everybody to put their questions. They can on the chat.
Yeah, by that
put the
time,
questions.
by that time, people can send their questions. And we welcome Mr. Chandu Shah from the Kenya.
Can you hear us, Chandu bhai? He can't hear us probably.
I think some. With us, Mr. Ravi Kadiwar is also with us. We also welcome Mr. Ravi Kadiwar.
Hello, Mr. Kadiwal, welcome.
Yes, sir.
Very welcome.
Yes.
With us, Suklaji is also with us. We welcome Suklaji also.
Very good. Welcome, Shuklaji.
With us, Mr. Shailesh Seth is also welcome, Shailesh bhai.
Very good. Yeah. Shailesh bhai, welcome.
And our guest, Mr. Danu Patel is also here. We can welcome Mr. Danu Patel also.
I think Setiji, you can continue with the further proceedings. In the meanwhile, if he joins,
may not be a bad idea.
yeah,
Okay.
Till he comes, we do that. And we invite
Yeah.
everybody to put up questions on the
Yes.
chat box.
Yeah,
because I
meanwhile,
have also sent him the message. In case if he comes, then it's okay.
can you check up Rohit ji with him? What is the status now?
I have sent the message. He is disconnected because of the network issues.
Some network issue is there. Okay.
I spoke to him. His computer went blank. So he's just trying to get it on.
We'll go for the next program till he's joining to us. So we'll go for the next program. Yeah.
Sure.
Yes.
Good afternoon and welcome to all the participants and members who are present in today's webinar. First of all, I thank Mr. Oliver Wandres for giving the wonderful presentation and accepting ROMA request for this webinar. As we all aware that Moulds, West Germany is the leading company of manufacture of world-class rotomolding molds. Mr. Oliver has presented on a various subject of advanced rotomold by aluminum cast technology and CNC machine molds. Indian rotomolding, as we are all aware, the Indian rotomolding industry is changing from water tanks to the non-tanks and custom molding product, it is the right time that we use world-class roto molding technology for our applications. In fact, Mr. Oliver has presented on the various subjects, covered the aluminum cast molds, CNC molds, and very high-tech molds for the roto molding applications. Definitely, it is a very informative for us. He has not only given the presentation of the high-class molds, he has given the various accessories, permanent mold curing system that is the need for our Indian industries. The mold automation, he has given a good presentation on the mold automations that is also required to save the time to increase our productivity. He has also presented on the automatic molds for the row molds. That is also very interesting molds, and the future is for the automatic molds. It also emphasized on the roto cooler molds for the internal cooling. That is also a very interesting subject, and the upcoming market is that internal cooling for the custom molding products and the various other applications where very high-tech molds are required. Internal cooling is also a very important features. So definitely it is a very good presentation for our members, and they will find a good application for the upcoming market. At this junction, I thank Mr. Anshuman Chaudhary from Supreme Industries Limited as a welcome speaker to welcome our guest speaker, Mr. Oliver. I thank Supreme Industries Limited and their directors, Sri MP Tapadeji, S.J. Tapadeji, and V.K. Tapadeji for your continuous support for Roma from the inception. I also thank the complete Supreme team who is always present on the webinars, and today I think Mr. Jayanto Majumdar is also present. I also welcome him on this occasion. I especially thank Mr. Rohit Rungta, our FGC board director, and our Vice Chairman L.K. Singh ji for their great effort. Today we are able to hear Mr. Oliver Wandres for today's webinar. Thanks, Rohit ji and L.K. sir. Now, as you know that Roma is always organizing the continuous webinar and the seminars during the complete year. We already almost completed 13 webinar with a different subject, with a different topic. Always we try to cover different subjects, starting from the raw materials, the technology, molds, machinery, the testing facilities. Almost all covers we are considering, and always we try to bring the world-class speakers, international speakers for our members. Today also, Mr. Oliver, who has come, he is the world-class #1 mold manufacturing company in the world, and a very high-tech molds manufacturing, and he is giving the very good presentation for us. So we always try to give the good, bring international speaker as well as the very national speaker who have got a very good deep knowledge of this subject and give very good knowledge to our members. As you know, apart from the webinar, we always conduct the other activities, and especially for our members, we conduct the testing facilities. We are also working with the CPAT for the testing facility and upgradation of their manpower, so people can take advantage with the CPAT to upgrade their operators, and they can send the operator to upgrade and understand the good knowledge for roto molding subject. Our membership drive is on. So I request all the non-members so far they are not made the member, become the member. They can become the member and take the advantage of the Roma facility. As last webinar we opened out of the international membership, and we have got a very good response from the international members now, and very attractive package for our international members we have done, and got a response from the metrics, the containers, and the Kaji, and soon they are going to become our members. And from the different countries, we are also getting the good response, and everyone want to become a member for the Roma membership. We thanks all the international members to become a part of Roma. I also thank our we have got a special packages for the membership that can be available. Details can be available by Vipul Bhai and Manoj Bhai or our websites. So you can take the details from the special membership as well as the sponsorship packages. ROMA, as you are aware, the ROMA eBay platform is also there. That is for the WhatsApp package where we can suppliers and vendors can come on the same platform and they can share their inquiries and do their business. That is free of charge for all the ROMA members. We also thank the Reliance Industries who always were giving the support to us, and special thanks to Mr. Raju Venkat sir and Mr. Vinodji, Yajnesh and Mr. Siddha. I think Vinodji is also always present in the thing. Today also is well present. We thanks Vinodji and the complete Reliance team who are supporting us on the program from the beginning. We also thank sponsors from the beginning: M Plus, Kaveri, Hira Automotive, Turbo, Aryan Plus, Puja Rotomag, Pius Rotomag, ML Industry, Swastik Rotomag, who always give the support from the beginning. And special thanks support to the Reliance Industry, who always give support from the inception for our supporting ROMA and upgrading the rotomolding industries in India. We are also getting the good supports from our resin suppliers, especially the GAIL, Indian Oil, HMEL, Opel, and Haldia. And we request them that they also become a part of ROMA and support us and upgrade the rotomolding industries in India. I would like to say that we have just recently completed 1 year and the last financial year we completed, and for that, for the accounting part and other things, we are conducting the first EGM meeting that will be held on 29th September 2020. It will be from 5 p.m. to 6 p.m. So I request all the ROMA members to come and attend on this annual meetings and understand and give their suggestion for the next year. So especially people should save this date for 29th September. It is only for the members to be present on this AGM. In this connection, now our next webinar will be on the 15th. That will be our 15th webinar, and that will be also a very interesting webinar. In this next webinar, it will be held on 26th September 20, and Matrix Polymer is going to give the presentation. So they are going to give the emphasis on the automotive sector's raw materials and custom molding raw materials. So it is going to be a very interesting seminar. So I request all the members and non-members to save this date for this next webinar. So it is a very interesting thing that we are conducting all the things, and we request our members to give their suggestions so we can upgrade our things in the future, and we can consider their suggestions for upgrading the rotomolding industry in India. Thank you very much. And we'll continue with I think whether Mr. Oliver is joined.
No, Sethi ji, still waiting.
Still waiting. I request LK Singh to give little brief till he's joining the thing about the ROMA.
LK sir, can you elaborate about
Our activities
scenario of India?
Well, it's difficult for me to continue his presentation because those are his unique parts, so we cannot say what he would do. But definitely,
the rotomolding industry in India.
The overall industry in India, what going on in India?
But certainly, I think people here in India should realize that we have to have very good quality products, and the only way is to have very good kind of molds. I realize the cost of the molds are very high, but it's an investment that is worthwhile. I believe one of the products you were showing was in India, the canopy of a rooftop, I think being done by Ashok Leyland or some other part of the south. But that is just one example. That's very highly successful product. Customers very happy. You have a lot of businesses. I'm sure very amply justified. The investment was very worth it. We must understand that we have to get good equipment and invest, to get a good quality product. And the returns are also equally as good. Nobody has regretted. All those who have gone into a high-end product have invested more, have won that much equally reward. So this is what our industry should understand, that is going to make a very big difference. So I think in case of this quality product, it is not just the cost, but the cost of production can vary. Like the clamps he was saying, the quick opening clamps. They've got system of quick deliveries also. So here they have a lot of solutions of the problems they've sorted out in the worldwide. Here also we can do. But we have to understand that investment required must be done properly. I think that is the primarily a problem or a hurdle for the Indian industry to do it. But I'm sure anybody who does it once will continue to do it once they see the benefit of it. So I think we need to do that. People like Oliver and other mold manufacturers and so on. We have to see how best we can do that to get our quality and so on. And it is not just, I said, that it is the part of the cost of the design, but it is also of the ease of production, production time, fuel time, like the wall thickness he said. Even wall thickness, that makes a difference of time. Your production time is all going to make a lot of difference. So I think we must do that. And Indian industry can meet the customer requirements, especially in the automotive sector, by using someone like that. And I think that is what we can do in other fields also. In the underground tanks also there is a lot of scope. And as you know, aluminum, but there are other fields like steel and so on to reduce the cost and so on.
Good.
Anyway, this is a very brief thing I could do as per of the moment, but and I think he's getting on time, and looks like it's difficult for him to come back on.
We'll wait for 5 or 10 minutes. Meanwhile, I request Mr. Gary to give a little brief about the ROMA activities. Is Mr. Gary is online?
Yeah,
He was.
Gary's here.
Gary, you need to wake up. You need to speak.
Yeah, I'm trying. I'm trying to switch on. I was listening, but I wasn't switched on. Sorry, what did you say, man?
You need to wake up.
Sorry, no. I'm awake. I was actually doing a design.
Okay.
What was the request there? Sorry.
Well, you need to speak something. You know, I can't imagine a German computer conking out in the middle of a presentation, but it has. But
well, they must come to India. They must come to India for IT help.
Yes, we can get it very low cost. We can get it fixed for him.
Yeah. No, I don't know what you want me to say, but
he's back.
sorry. Really? German's back.
Sorry. That computer died on.
Welcome back again.
Welcome back, Mr. Oliver. Yeah.
I'm extremely sorry, but the computer just died on me for some reasons. I used a different now, but that took a while.
Maybe we decided you need Indian IT help.
I sure do. Yeah, it maybe was just too heavy with all those ejectors. It just went out. Well, anyway, there were not that many slides to go anyhow.
Okay.
I hope you all had a good time waiting for me and it was not too boring, but I see some people left already. Okay, so I wanted to conclude that most of the spare parts we nowadays carry, you can easily find in our new web shop. You can check different branches, if it's vendings, air application clamps, or all other sort of interesting features you will find right on the website. Okay, now do I switch this over? Hope I'm having no problems again. It's not working as it should work. This is brilliant. I love it. Wow. Next thing I was to talk about, but I cannot really show the slides, is that even if we have really, really good molds, I always, okay, now we start at the first page. Interesting. Even if we have really good molds, what I also always reckon is not just keep the good mold as it is, but you need to look at the mold maintenance, because you can start off with a really good mold, but if you don't keep it in a good shape and condition, the best mold is worth nothing. And typically, here are some pictures of molds as we sometimes get them back from our customers. So you see a lot of dent areas, scratched areas, and the picture to the right, this shows our worst nightmare. If you have a mold, and it can always happen on each and every mold, that things break, or an operator forgets a loose piece or whatever it might be, and you have leakages of powder, but don't you ever keep on running with molds like this. I mean, this is messing up the mold and the product, but it's also messing up all other molds on the machine. So it's always important to keep the molds nice and tidy in order to have a good production run. Here are some more shocking pictures of sometimes the molds look like when we get them back. In the picture on the lower side, you see actually there are a lot of clamps missing. Guys have tried to open the molds, not really educated, but with crowbars, they have completely distorted the parting lines. You need, in your operation, you need to find ways to frequently look at the molds and trying to maintain them in a good shape. If you have molds to work with like this, I think it's not really a good production. So what we recommend is to do the mold maintenance frequently and in time, perhaps, and ideally have maintenance plans for all the different molds. At least check the tightness of the mold flanges, that the fasteners or screws are where they need to be. Otherwise you have leakages, and that's the worst thing to happen. Control the overall conditions. You would not want to produce with molds where you have half a plastic part sticking from the outside of the mold. This is way too slow, messing up your complete processes. Trying to have standards so you don't have to have different elements for all molds, but have standard stock items. And what is also really important, trying to listen to the crew that have to work with the molds. They typically know best what needs to be done at various molds, or where there is potential to optimize or even upgrade the molds. That is like a very easy maintenance plan could look like. Some pictures for the operators, so they know what elements they have to maintain and look after. If it might be a greasing plan for clamps, or cleaning the parting lines, or maybe even just a plan that every cycle they need to look after the venting. If you have this in place, then the production can run a lot smoother. Or if you have complicated molds, we recommend to have operating instructions. So the guys that maybe have not ever worked with such a mold know in what sequences they have to open the mold, and in what sequences they have to load and close the mold. That is easy stuff to produce, but it can save you a fortune in production. Ideally, you would have a complete CAD model on the molds. Of the complete CAD model, you can easily run off spare or attachment part lists, so you can keep this all in a good line. The same is with mold repairs. Don't wait too long. If you have molds where you have some issues, have them repaired in time. Typical mold repairs could be on the surface injuries. There could be cracks in the molds. If you wait too long, a crack will carry on. It will be bigger. It will adopt plastic in the crack. If you have a crack somewhere in the mold or in the frame, do it as soon as it pops up. The mold parting line should always be repaired as soon as you have any issues there. Same for mounting blades. Sometimes we see guys where the mounting blade is just with one little weld line still on the mold, but they still keep on running. That is a potential danger to operators, but also to the production. So all those repairs, they should be always carried out and attacked as soon as they were made you or find. The upgrading of the molds, again, we recommend to do this an assessment frequently. Don't just buy a mold and then predict that mold is bought off a good producer and now it's producing the same thing for 20 years. Now and then there might be new techniques, there might be new reasons for a mold to be upgraded. It could reduce your scrap rates. Sometimes you could improve the mold in terms of a better wall thickness distribution, or you could see what difficulties there are in production. Maybe the handling can be optimized. Maybe the post-molding operations could be minimized or optimized. Sometimes the product could be better if you do some upgrades, or the production numbers can be bigger. So there are all sorts of different ideas. That is an example of upgrading or repair of a mold, a very bad casting mold, which a customer of us came to us, a big bold mold in Norway, and it was full of porosity. They basically could not produce with the mold. They had to spend many hours per product to dress up the product, to rub out all those porosity pits, and they found it was money well spent for upgrading, for healing the porosity with our BMC C10 coating. So we can apply this, rub this down, apply certain layers, and then the porosity will be closed. And now they can produce with this mold without having to spend a lot of time in extra finishing of the product. Or you can have improvements on the wall thickness distribution. You can easily apply some so-called profit pin on molds. If you find you have areas where you have too little wall thickness, just TIG weld some pins in there to rip up the airstream to create more surface area, and this will easily adopt more material in these areas. Or work with venturis, or rather than dropping powder in manually, you could retrofit drop boxes to molds. So it's there can always be better things being done with a mold. Even if you start out with a very easy shape mold, it should not be frozen as my computer was. It always needs to be uplifted and uplifted. You can always do better. And especially in nowadays times, we see that many people invest in upgrading their mold, where the production is still slow with the COVID pandemic everywhere and few new jobs coming on, but people are actually very keen to improve their current production as good as can be. This is an example of a steel mold where we actually have adopted pneumatic lamps to a steel mold. That's also a possibility. We can use your existing molds and together in a dialogue can find ways to spot your problems and trying to overcome or improve possible problems. So it's not that we only have to produce new molds, but we are also more than happy to help and guide you how to actually improve your production as there is at the moment. And that was basically my slides which I had prepared. I had a nice coffee break in between waiting for my computer, and I hope you enjoyed that little webinar and there were some interesting things in for you. Thank you. And thank you very much for waiting for me for such a long time.
Thank you, Mr. Oliver, for giving the wonderful presentation.
Thank you.
For today's morning. Thank you. Now I request Mr. Manoj Patria from Reliance Industries to have the question and answer hours. Mr. Manoj Patria, please.
Yeah, thanks, Setiji. And first of all, many thanks to Oliver for accepting our request and giving us a enlightened view of in high quality rotomolding molds, and almost 85 technocrats and industrialists are attending this webinar, and I will give you full detail of all the attendees to you by mail. And first of all, almost all the points you covered in your presentation. So I didn't get any much queries from participants. And you have covered venting, cooling, coatings, robotics, and all the sectors and major mold techniques. All the points are very well covered by you. And very soon I will send full detail of attendees. And if any queries I got from any participant, I will share with you very soon. Thanks a lot, Oliver. Over to you, Satish. Yeah, thanks. Over to you, Satish.
Yeah. Now we request all the members, they can ask their question answers if they can directly question anything doubts are there.
Yeah, if any person have any question, you can ask directly.
Yeah. So yeah, Oliver, that was a very nice presentation given by you.
Thank you.
So one thing I want to ask, you have shown the automated spiders on a diesel tank molds.
Mm-hmm.
So just wanted to understand for getting these automated spiders, do we need to have any special provision on the rotomolding machine as well, or it works on the usual machines?
It works on the usual machine. Typically, what has to be said, if we automate the molds, they are a little bit heavier than manual molds. So it is always good if a mold, if a machine has a higher load capacity. But other than that, all the automation will be worked with external compressed air, so the machine does not have to have any different requirements.
Fine, good. Now the second thing is, now you could, how do you perceive the Indian rotomolding market for the near future, and what are your plans for coming and settling any kind of facility in India for the mold making, because that's a very important subject, or that's a very important you can say area where Indian market rotomolding industry is lacking behind. So how do you see that in the near future?
That's difficult. What we have tried to work with is what I said before with the Reinhardt technique, in terms to have a basis for our permanent release coating, because that was our first approach. To have the mold coatings, it does not really make sense to have the molds being traveling all the time. So that is a must to have the coatings in the country, which we have also in other countries like with North in US, etc. And our idea was to maybe in the future share technologies and ideas with Reinhardt to have a basis in India. We still see no chance to actually transport the foundry bit to India, as we learned very hard in the past how difficult it is to actually set up such a foundry department. And still we have to cope with many issues. It's the environment, etc. So we would rather think it might be at a certain point a road where we would produce the molds here and the engineering, maybe do the raw casting, but consider to have the handwork bit of the mold making being carried out in India. But that is at this moment in time a little bit too early to be said. But I think that is basically our thinking and ideas for the future.
Fine. Thank you, Oliver. Thank you.
Mr. Oliver, one question that you are given the emphasis on the PMC coating on the molds. Is it possible to have the CNC steel molds also?
Yes, yeah. It's basically possible on all metallic surfaces and all different molds.
Do you supply the chemical or technology for the existing molds?
we have supplied the technology and the chemicals or the liquids to Reinhardt. They are licensee for some coatings, and there might be more to come. So also, we cannot just basically supply the liquids to molder to apply, because the coating itself requires quite some sincere hardware. You cannot bake it in a gas heated oven. It needs to be an electrical heated oven to bake in the coatings. Plus, this needs to be on a rather clean oven environment. Otherwise, you would have all sorts of figures in the coatings. So therefore, we rather work with licensees. Yet something new might be the new Edelweiss coating. This is a coating where at this moment in time we are experimenting with molders in Poland and molders in Czech, where we can supply just the liquids, and they can coat the flanges and also the mold shells, especially for larger steel molds in-house. Because this is a coating where we don't need to have the full heating up process that only bakes in at 200 degrees. So that is the only one that would work as an option.
It will be a permanent coating, or we have to apply?
That is a permanent coating. So one time it is baked in, it will be there unless some really brute operators would damage it with a chisel and a hammer. But other than that, it's permanent.
Oliver,
yeah,
you were talking about mold release, auto mold release and all. Is it possible to get it, like suppose you wants to get it from you, but you need to design it? Do you all help in that, or you just have to buy the parts and then assemble it or something like that?
Both possible. I mean, we have made many molds all over the globe which are automated, but we have also many mold projects for New Zealand, Australia, Brazil, where the guys have molds or produce the molds themselves, especially larger molds where shipping would cost a fortune, and we help them to design the automation. We would supply the hardware in terms of the springs and the clamps, and we will guide or engineer them how to best fit them and apply them. But the actually physical work is then realized at the molder in the certain area.
Oh, yeah. Okay. Thanks. Got it.
Any more questions?
Yeah. Priyanka Kothari, I think she's here. Miss Kothari, Priyanka ji.
Yeah, hi. Thank you, Oliver, for an amazing informative session. I just wanted to ask you, could you throw some light on the snap swords that you were mentioning in the presentation?
Mm-hmm. The snap swords, you mean? Yeah, it's basically a very easy system. It's a spring-loaded little ball which will slide into the thread of an insert and hold it in place. And it's rather simple to just stick on an insert on that snap sword rather than having to screw in all the thread lengths, which is quite time-consuming. It might not really be a thing to consider if a molding has like 2 or 3 inserts, but many times we come across molds where there are like 40, 50, 60 inserts, and if you would always have to screw these in, it's a horrendous time to apply this. And with a snap set, you would just basically take the insert, plug it on, and when you demold it, you would just easily slide it off, and the molten insert remains in the plastic product.
Is it possible to share like a small video or something, like how it would work?
Yes, I can do that. Not possibly right now, but I can pass this on.
Okay, yeah, that works. Mm-hmm. I can.
Okay.
Any more question from?
No, strategy. Over to you. Thanks.
Okay. So now I request Mr. Krishna Marathe Saab for the from the Shift Industries to give the vote of thanks and conclude today's webinar. I request Marathaji.
Yeah, good afternoon. Thank you, Seti sir. Honorable Roma members and non-Roma members, respected speakers and sponsors, and my dear Roma FGC board members. Myself, Krishna Marathe, Managing Director of Swift Technoplast. Swift is a pioneer company in business of manufacturing high-end rotomolding products. We are into non-rotomolding, material handling, plastic pallets, icebox, and many custom molding products, and market with the well-established brand name of a Swift. Our products are well appreciated for its unique design and performance in a domestic and international market. Our customers are like Unilever, Parle, Godrej, Cadila, Pyramid, so on. We also export our products more than 15 countries like Oman, Bahrain, Saudi Arabia, and so on. And of thanks. Okay, I would like to thank seniors and superiors for showing trust in Roma. Because of you only, Roma becomes world's third largest association in these industries within a first year. I'm extremely elated to announce the successful closure of this today's 14th webinar. We got overwhelming response and love of across the roto industries. And we sincerely thanks to all Roma members for attending this series of webinars and getting knowledge enhancement and learning. I would like to express a big thanks to our today's speaker, Mr. Oliver Wandres from Moulds, Germany. Moulds is well established, world famous name in rotomolding sector and have a business in almost all the major countries across the globe. As we all aware, post-pandemic world market scenario has transformed, and now it's a need of the time for Indian rotomolders to manufacture quality, zero defect, zero effect products. Obviously, in rotomolding designs and molds plays a very important role. What Mr. Oliver has shared today, mold, products, and case stories of royal family on other molds technical details, where we can understand the possibility and technical ability you have developed in rotomolding. Various aspects of molds, mold accessories, and automation technology you share in your today's presentation takeaway will help us value addition, and technocrats here will definitely try to implement in their rotomolding industries. Swift is also keen to develop innovative products with the help of Moulds in near future. And thank you, Mr. Oliver, for being here and sharing your valuable knowledge. Also, I'd like to thanks to our Roma FGC, all committee members for tirelessly working and arranging transformative knowledge packed webinars continuously for rotomolding fraternity. Further to inform you all that very soon we will be meet again on our next 15th webinar on 26th September 2020. Please do attend. Many thanks. Thank you all. Thank you very much.
Thank you, Marathaji, for the good presentation.
Thank you, Mr. Sethi. It's over to you now.
Thank you. Thank you.
Thank you, sir. Thanks.
Thank you, Marathaji, and
Thanks,
thank
Oliver.
you once again, Oliver, Mr. Oliver, and Mr. Ansuman for the today's webinar. And I thank all our FGC board directors and the members who are presenting today's webinar. Thanks to all. Thanks. Yeah.
Danuji here. Danuji.
Thank you.
Hello. Danuji here.
Hi, Oliver. Mukesh, how are you?
Mukesh bhai is there? Oh.
Yeah, Mukesh bhai is here.
Yes. Welcome, Mukesh ji.
How are you?
Fine, fine. Now you can conclude.
Sorry, I was not attend the entire seminar. Pretty good. Hi, Oliver. How are you? Thanks for the time.
Thank you. How are you? Traveling?
All good. Yes, I'm traveling.
Thank you, Mukesh bhai, for joining at the last moment.
Thank you.
Yeah, thank you. Thank you, Mukesh bhai.
Whatever I do. Yeah.
Thank you, LK sir.
I think Sethi ji, Danuji here. So Danuji, are you here?
Mr. Danu Patel,
Thank you.
are you there?
Yes, hi, I'm there. Go ahead.
Yeah, welcome. Yeah.
Welcome, sir.
Thank you.
Say
Thank
something,
you.
sir.
Say something. Oliver, great job. You have brought rotational molding closer to injection molding, which is a big achievement considering that every mold is different and the outputs are limited, the runs are limited. But I think you've done a lot of work and dedicated. I think you're the only company in the world who's dedicated only to rotational molding. Everybody else does a little bit of everything, but Moulds is, I think, for years together working only on rotational molds and trying to automate them as much as you can. Like most inventions that come out of NASA or that, I think you guys are bringing this to us mainly based on the automotive industry, because that is where the numbers are. So probably the first people to jump in are going to be the people from automotive industry, because that is only where you have the numbers that are required to justify mold costs and coatings as well. We are happy to do a coatings or quotes for coatings for anybody who's interested. We have had this technology now for almost 3 years. We have the ovens, the equipment, everything here in India. So you're welcome to send your inquiries. Okay. Thank you. Thank you, Oliver.
I think Mr. Dalvi Saab is also there. Welcome, Dalvi ji.
Dalbir ji.
Is there? I think left.
I think left, sir.
Okay, he's left. Yeah. Okay.
He joined and yeah. Thanks, sir. Thanks to
all the people who have joined today.
Yeah.
And thank you, Rohit ji, again for your great effort.
And thank you all for waiting so long for me.
Yeah,
oh, thanks. Thank you.
Thank you, everyone. Thank you, Oliver, for accepting the invitation and speaking us today.
Thank you for the invitation. And have a nice weekend, all of you.
Yeah. Okay. Thanks a lot. Bye.
Yeah.
Gute Wochenende, Oliver.
Danke, Ronny. Dir auch.
Cheers, Ollie. Cheers.
Cheers.
Bye.
Gary is there still? Yeah.
I'm still here. Goodbye. Cheers, everybody. Have a great weekend. Bye.
Cheers.
Bye.
Bye.
Bye. Bye. See you. Bye.
Bye, sir.
Bye, everyone. Yeah. Thank you.